this is lecture number 4 of work, energy and power. Up till now we have discussed about work energy theorem, right? We have solved the questions based on work energy theorem and how to calculate work done when force is variable, right? Okay, so now we will understand the other form of energy, which is potential energy. See, basically energy is ability of doing work, ability of doing work, right? Now there are various forms of energy, right? In the lower classes you must have studied that energy can neither be created nor be destroyed. Energy can neither be created nor be destroyed. Clear? You just can convert energy from one form to another. So basically there are many different forms of energy: kinetic energy, potential energy, electrical energy, right? Magnetic energy, etc. So these are all the various forms of energy. These are all the various forms of energy. A body will have kinetic energy only because of the motion, virtue of its motion, right? Half mv square. If the body is moving, it will have kinetic energy, right? Similarly, now today we are going to discuss about potential energy. Right? What is potential energy? So it is also a form of energy, right, which can be achieved by the configuration or by the position of the object, right? The energy possessed by any object by the virtue of its position or by the virtue of its configuration, right? That is known as potential energy. For an example, the overhead tanks in our home, right? The water in overhead tank will have potential energy because it is at certain height. Because it is at certain height. When you will study this in 12th. When two charges are kept at certain distance, they will be having a potential energy because of their arrangement, because of their positions, right? So basically, potential energy is because of the virtue of the position of the object or virtue of configuration of the object. Clear? Since overhead tanks are at certain height from the surface of the earth, it is having, the water in it is having potential energy. If the same tank, if we keep on the ground, it will not have any potential energy, right? The position changes, and because of this changing position, because of this configuration arrangement, it is having potential energy. Clear? Now potential energy are also of different types. That means we'll study about gravitational potential energy. In 12th you will learn about electric potential energy, magnetic potential energy. Let us confine our study to gravitational potential energy, right? Okay, so potential energy, it is because of, or it is due to the position or configuration of the object. Clear? When you are wounding any toy, right, you are changing the configuration of that particular screw, right? And when it gets unwound, it moves. That means while winding, some energy is stored in that screw. That is known as potential energy, because you have changed its configuration, you are changing its position, right? So because of change in configuration or position, the energy developed is known as potential energy, right? Okay, now how to calculate gravitational potential energy? Gravitational potential energy. Basically, energy means work done. More the energy spent, more will be the work done. So actually work done is equals to energy spent. Suppose this is ground, right? You are holding a body of mass m at a height y1, right? Now you wish to take this body to a height y2, In order to take this body from a height y1 to y2, some work has to be done against the gravity, right? Because gravity will not allow you to take it upward. You have to perform some work against the gravity. If you are leaving this, it will go down, it will not go up. So in order to take it to higher position, some work has to be done against the gravity. This work done will be stored inside the body in form of potential energy, right? And you you can see that you have changed the position of the body. You have taken the body from one height to any another height. Because of the changing in the position, some work has to be done, and because of this work done, it will possess some energy. This is known as potential energy. Clear? So what potential energy will this body possess? So work done equals to, you are taking the body in upward direction, so displacement is in upward direction, right? Let us say the displacement as y2 minus y1. This is y1, this is y2, so this is y2 minus y1. Clear? This is the displacement in upward direction. mg, the force which will be in downward direction. Now, what is work done? F dot d. So it is F d. What is the angle between force and displacement in this case? 180, because mg is acting in downward direction, displacement of the block is in upward direction. So the angle between them is 180. So force is mg, displacement is y2 minus y1, cos theta, cos pi minus 1. So finally work done is equals to minus mg. Let us say y2 minus y1 as h. Work done is minus mgh. This work done will be stored in the form of potential energy. Potential energy is a scalar quantity and it is denoted by U. Right? Negative sign is because work is done against the gravity. Clear? So this will be the potential energy mgh. Value wise, mgh will be the potential energy stored inside the body of mass m when you are taking it to a position y2 from y1. Clear? Okay, now value wise potential, see, potential energy is denoted by U, and now potential energy is value wise mgh, or you can say it as mg y2 minus y1, whatever. Okay, now let us differentiate this du by dr. Okay, it was minus mg, du by dr or du by dh. H is changing, so du by dh. So this will be d by dh of minus mg h. So du by dh will be equals to minus mg, h is minus. What is mg? F. So F is equals to minus du by dh. This equation is very important, students. F is equals to negative of rate of change in potential energy with respect to distance. Force is equals to negative of rate of change in potential energy with respect to distance. Right? In general, we can say it as F is minus du by dr. F is minus du by dr. We will solve the question based on this equation. Understand this equation very clearly. Force is equals to negative of rate of change of potential energy with respect to distance. Force is equals to negative of rate of change of potential energy with respect to distance. Right? Okay. Second thing, if we are suppose the body of mass m, say it is at a height y1, we are taking it to a height y2. In first case, we are taking the body from y1 to y2 through this route 1, right? And in second route, we are taking m1, we are taking from y1 to y2 along this route. So there are two routes. First route in which we are taking this mass directly from y1 to y2, and in second we are taking this mass from y1 to a curved path, and then we are putting it at y2. So basically energy is work done is force into displacement, right? One thing should be noted that we will not consider any other force. That means any kind of resistive force are not included in this derivation. That means we will not consider air resistance, we will not consider frictional force. Neglecting all the forces, this equations which we are deriving will be true. Okay, so now in this case, work done or energy is force into displacement, right? Displacement means you just have to join the initial and final position. That means whether you are taking the mass from root 1 or root 2, in both the cases the displacement will remain the same. Displacement is this. Displacement means just join the initial and final position, right? So displacement in both the path will remain same. So work done, force is mg in both the cases. Displacement is also same. So work done in both the cases will remain same. That means potential energy will remain same. Clear? Right? So now definitely the question might arise that if you are taking any object in this route and then you are taking in the longer route, then you will get more tired. That is definitely correct practically, because in practice we cannot ignore friction, we cannot ignore air resistance. Because of this we have to put extra effort, and that is why we get more tired when we are taking it from a longer route. But as I stated earlier, that we will not consider any kind of forces, frictional force, air resistance, any other losses we are not considering. In this case, it proves that work done does not depend on path. Work done does not depend on path. Right? It depends only on initial and final position. Finally, we have derived this, mgh. H means y2 minus y1. So y1 represents initial position, y2 represents final position. Right? So work done does not depend on path, it depends only on initial and final position. This kind of work done or this kind of field, we are working in gravitational field. We are working in gravitational field because we have to perform some work against the gravity. And any body having a mass will produce gravitational field. Any body having some mass will produce gravitational field. So we are working against the gravitational field. So this field in which work done depends only on initial and final position and does not depend on path, this field is known as conservative field. This is important. We'll use this conservative field in 12th standard. Right? So what I mean to say is that gravitational field is conservative field. What does this mean? Whenever you are working in the gravitational field, the work done will not depend on the path. It will just depend on the initial and the final position of the body. Right? In our case, we have seen that if the initial and final position is same, you move in either of the path, work done remains the same. Right? So this field, gravitational field in which you are working, does not depend on the path. So this is known as conservative field. Clear? And the gravitational force is known as conservative force. Gravitational force is known as conservative force. So finally, potential energy is mgh. Gravitational potential energy is mgh. Right? We can say that m and g are almost constant. So potential energy will change according to height. One important point about potential energy is potential energy depends on reference, and so change in potential energy is more important than its value, than its absolute value. What does this mean now? Well, this is the last point about potential energy. Then we'll discuss in the next video about the total energy, how potential energy decreases, how it will increase, accordingly what will be the change in kinetic energy, how total energy will remain same. These are very important topics and very useful in your competitive exam. See, what does this means? Potential energy depends on the reference, and so change in potential is more important than its absolute value. That means you will see in your books also, and in many questions you will write it as work done is equals to change in potential energy. You will not write as work done is equals to energy. Right? See, reference is to be mentioned. If I am taking this my palm as the reference, and if I am placing a body here, this will not have any potential energy with respect to this, with respect to my palm. But with respect to ground, it is at certain height. With respect to ground, it is at certain height. It will have potential energy. See, for this use the equation mgh. There is no height. So potential energy is 0 in this body when you are considering palm as your reference. If you are considering ground as the reference, it is at certain height. Clear? So the value is not important. The change in energy will give you work done. Right? If you are securing 40, out of 40 if you are securing 25 marks, right? So then you will understand that in order to get 40 marks, you have to perform a work done of next 15 marks. So how this can be removed? 40 was the total, you have secured 25, so the difference will give you the amount of work done. In the same way, the change in potential energy will give you work done. Only the value of potential energy cannot give the work done. That is why it has been said it is the change in potential energy which is important. If a change in potential energy is of 20 joule, it means work of 20 joule is done. If the body is having a potential energy of 10 joule, that does not mean that work done is 10, provided the reference should be given. If your reference is given that yes, initial energy is 0, right, and then the final energy is 10, then you can say that yes, work done will be 10 minus 0, that is 10. Is it clear? So that means whenever you are defining energy, define a reference point. Only then you can calculate the amount of work done, right? And therefore work done is always equals to change in potential energy, right? Now if your reference energy, you are taking ground as reference, suppose you are taking a ground as reference, and if the object lies on the ground, then the initial potential energy is 0. So your reference potential energy is generally taken as 0. So now if you are taking this to a height h, so work done can be, so final energy will be mgh. So work done can be written as final minus initial. Work done can be written as final minus 0. So work done can be written as u. Right? This is okay. But otherwise you need to write as work done equals to change in potential energy. Well, this was a concept about potential energy. Still we have to relate the energy, potential energy and kinetic energy, mechanical energy, and we will also understand the law of conservation of mechanical energy. But this we will study in the next video, and then we will solve all the questions based on these topics. Okay.